Welcome to another video for valuation of bonds and shares. In this video, we'll understand the fundamentals of semi-annual interest payments in case of bonds. So let's take an example of an annual interest payments for bonds. So let's say this is the time scale 1, 2, 3, and 4. So in this case, INT is the interest paid yearly. So INT, 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 and INT. Now, at the end of the tenure, the investor will be paid the maturity value, which is M. So M is the maturity value, and KD is the required rate of interest, and this is annual. So this is KD. So when this was the case, that is the interest were being paid on an annual basis, we said that B0, so B0 is the present value of the bond, is equal to sigma T is equal to 1 to N INT divided by 1 plus KD to the power T plus M divided by 1 plus KD to the power N, where N is the number of years to maturity. So in this case, N is 4. Now let us take the case of semi-annual interest payments. So let's say this is the time scale. Now here we had the total tenure as 4 years. So I have marked 4 sections here, 1, 2, 3, 4. However, this is the case of semi-annual interest payments. So interest is being paid at every 6 months. Now, if INT is the interest being paid yearly, so let's understand this. So INT actually is, let's say, 100 rupees. Now, how is this INT calculated? So for example's sake, let's say the interest is 10% of 1000 rupees. 1000 is the face value and 10% is the interest rate. So then we get yearly interest of 100 rupees. Now, if this is 6 monthly interest, then we'll have the interest as 5% of 1000 for 6 months. This will be the interest. So this becomes 50 rupees. So basically, your annual interest is becoming half. So the interest that is being paid to the investor becomes INT divided by 2. So INT divided by 2, INT divided by 2, and so on. And at the end also INT divided by 2. Maturity value remains the same because the face value is the same. So at the end of the tenure, the investor will get M as the maturity value. Now KD, this is the required rate of interest. So KD is an annual interest rate, which is the market rate or the required rate of return that the investor is looking for. Now, if we are taking the period as half or semi-annual, then the market rate of interest also has to be halved. So this becomes KD by 2. So KD by 2 becomes the interest rate. Now N is number of years to maturity. So in semi-annual interest paying bonds, N will be doubled because now there are 2 times the number of periods. So instead of years, now we are considering periods. So there are twice the number of periods. So N is actually 2 times N. So basically what we have done here is this N became 2 times N. Interest became INT divided by 2. KD or the required rate of return became KD divided by 2. N is 2 times N. So this becomes the formula for value of a bond in case of semi-annual interest payments. Now let's say this was quarterly interest paying bond. So that means in a year there are 4 times when the interest is being paid. So then what will happen? N will become 4 times N. Interest will become interest divided by 4. KD will become KD divided by 4. Now, I personally find it easier to standardize this formula in terms of N. And instead of doing 2 times N, 4 times N, I prefer considering N as the number of periods. So the formula for annual payments was T is equal to 1 to N INT divided by 1 plus KD to the power T plus M divided by 1 plus KD to the power N. So if we consider N as the number of periods and then convert all the remaining things as per the definition of the period. So let's say this is a quarterly interest paying bond. So in that case, a period will be defined as 3 months. Now, if interest is given in yearly format, we should convert interest in the quarterly format. If KD is given in yearly format, we should convert that also in the quarterly format. So then we just have to remember one formula, not get confused by whether we should use INT divided by 4, KD divided by 4 and so on, and logically enter the values for interest, rate of return, number of periods. Let us take an example to understand this concept better. The face value of a 10-year 10% bond, that is with 10% coupon rate, is rupees 1000. The interest is payable semi-annually. Assuming 12% required rate of return of investors, compute the value of the bond. So let us first note down the information that has been provided to us. So maturity time frame is 10 years. Coupon rate is 10%. Now this is annual interest. Face value is 1000 rupees. Interest is payable semi-annually. Required rate of return is 12%, and we have to find the value of the bond. Now here the maturity time frame is 10 years and the interest is payable semi-annually. So basically the interest paying periods, or the number of periods in which the interest will be paid, will be 10 multiplied by 2, which is 20. So let us draw the timeline for this. 0, 1, 2, 3 and so on, and then we'll have 19 and 20. So each of these is 6 months. So basically n, or the number of periods, is equal to 10 into 2, which is 20. Now the interest is paid on the face value. The annual interest is 10%. So half yearly or semi-annual interest will be half of this rate, which is 5%. So 5% of 1000 rupees is the interest which is going to be paid at the end of every 6 months. So interest becomes 5% of 1000. So that is 5 divided by 100 into 1000, which is 50 rupees. So the interest being paid is 50 rupees at an interval of every 6 months. We'll take the maturity value as the face value. So at the end of the tenure, the investor will also get 1000 rupees. Now the required rate of return is 12%. So this is nothing but KD. Now this is the rate which is prevalent in the market for other similar bonds, but this is the rate that they are offering on an annual basis. So for semi-annual basis, the value of KD becomes 12 divided by 2, which is 6%. So 6%. So in order to find the value of the bond, which is B0, which will be the value of the bond at this point, basically we have to add the present value of all the cash flows that this bond is going to generate. And this present value will be calculated at the required rate of return that the investor wants. So basically we have to find the present value of each of these cash flows and add them up. So let's note down the formula for that. So B0 is equal to sigma T is equal to 1 to N INT divided by 1 plus KD to the power T plus M divided by 1 plus KD to the power N. So let's plug in the values. T is equal to 1. Now N is the number of periods, which in our case is 20. Interest is in terms of the 6 monthly periods. So interest is 50 rupees divided by 1 plus KD is 6%. So 0.06 to the power T plus M is 1000 divided by 1 plus 0.06 to the power N, and N is 20. So let me put this 20 here. So what does this mean? So this means, the first part means that T has to be replaced with the values from 1 to 20, and all of them have to be added. So it will be 50 divided by 1.06 to the power 1 plus 50 divided by 1.06 to the power 2 plus 50 divided by 1.06 to the power 3, and so on up to the point where T is equal to 20. So that is going to be a very time consuming calculation. So instead of doing that, we'll use a different method, which is to use the present value factors. So same thing we'll do with a different method. So this is what we had written down previously. Now this can also be written as INT sigma T is equal to 1 to N into 1 divided by 1 plus KD to the power T plus M into 1 divided by 1 plus KD to the power N. Now this portion actually represents an annuity, and this portion in particular represents the present value factor of an annuity, and this portion represents the present value factor of a lump sum. So this can be written as INT into present value factor of an annuity, where the rate of interest is KD and the tenure is N, plus M into present value factor of a lump sum, with KD as the rate of interest and N as the number of periods. So now let's plug in the values. Interest is 50 into, now present value factor of an annuity at KD, which is in our case 6%, and N is 20, plus M is 1000 into present value factor, again KD is 6% and N is 20. So this becomes 50 into, now the value of this factor is 11.470 plus 1000 into 0.312. So this becomes 885.5 rupees. So this is the present value of the bond. Now there are other methods also to solve this, like using the formula for an annuity or using the financial calculator. I have explained them in details in the videos for time value of money, so you can try those on your own. The answer should be the same, that is 885.5 rupees.